Hello, lovely Math 1 students. Today we are going to talk about using proportions to solve for missing parts. So let's make sure we remember what equivalent fractions or ratios are. So remember that a ratio is just a fraction, a relationship between a numerator and denominator here. So if we wanted equivalent fractions or ratios, they just need to be equal in value. So if you have a ratio or a fraction of 1/2, that would be equivalent or equal in value to 4/8, or 6/12, or 5/10, or any number of options for equivalent fractions to 1/2. So equal in value. If you have 4/8 pieces of the chocolate bar, that's the same as having half of the chocolate bar. All right, if we are drawing our slope triangle here, they tell us that triangle A is going to have a slope of 3/2. So my rise is 3 and my run is 2. So I'm going to rise 3 and I'm going to run 2. Okay, and that is my slope triangle. Remember, slope triangles can be, we can keep going with them and get different slopes that will all simplify to be equivalent ratios. So if I wanted to go again, right, so triangle B over here, I need to get to a run of a total of 6. So if I were to go up again here, I would go up 3 more. Oops, why did I do that there? Try again for now. If we were to continue with this, we would go up 3 from here, up 3 more, and then over 2. And that would get me, so now I've gone over a total of 4. Now I'm going to go up again, up 3, over 2. And what I have just created here is now we have a run of 6 total. So I've created a big slope triangle. Let's do that in a different color here. I've created a big slope triangle. Right here, where my overall rise and my overall run has changed. So now I've risen a total of 3 times, 3 times 3. So I'm gone up 9, my rise is 9, and I've gone over 2 plus 2 plus 2, 6. So I went up a total of 9, and I went over a total of 6 to get my new triangle. So if I wanted an equivalent slope triangle that had a run of 6, I would have to rise 9 to match that original slope triangle. Algebraically speaking, what that's going to look like is a ratio, a proportion, right? So what we have is we know we want 3/2 to be equivalent to some rise, I'm not sure what, over the run of 6. So when we don't know what something is, we just replace it with a variable. So all I'm going to do here is cross multiply and solve for x. So in other words, I'm going to take these two and multiply 6 times 3, and I'm going to set that equal to 2 times x. Cross multiply. So we can cross multiply to solve here. 3 times 6 is 18 equals 2x. Divide by 2, divide by 2, and we get 9 equals x. Again, if we drew our slope triangle, we get the same exact thing. This will match algebraically. The other way to look at these, and this does not always work, but it's a good way just to check your thinking here. What we know is that these need to be equal, right? So what would I do to 2 to make it 6? I'd multiply by 3, right? I would multiply by 3. So up here, I need to also multiply the top by 3, because that's the way we keep fractions equivalent. Basically, we're multiplying by 1. 3 divided by 3 is just 1. You can multiply anything by 1 and it will stay the same. So when I multiply by 3/3, I get 9/6. So that I know my missing value here is 9. Okay, so just 3 different ways that we can think about these problems. All right, so if we have a rise of 1 and a run of 3, and we want our new triangle to have a rise of 2. So now I need to double up 1 more, over 3 more. So my run should be a total of 6, right? I should run a total of 6. So I believe that my new slope triangle will be 2, 6 based on my triangle math here. Algebraically, I'm going to say 1/3 needs to be equal to 2 over x, because this time they gave me the rise. They told me I want to go up 2, and I need to find out the run. Same exact process, though. We're going to cross multiply. 1 times x is just 1x. You don't need the 1. 2 times 3, again, cross multiply, is 6. X equals 6, just like in that other example. This one, same idea. What would, well, no, moving on. Okay, all right, so if we want to solve these algebraically, because often that's the easiest, we're just going to cross multiply. So we're going to do 5 times 8 is equal to 3 times x. 5 times 8 is 40, equals 3x. We divide by 3 on both sides, and we find that x is equal to 13 1/3. So the ratio on the left is 5 over 3. The ratio on the right is 13.3 repeating. That's the same as 13 1/3 over 8. I know that they are equal because both rates simplify to a decimal of 1.6 repeating. So what that means, and I did a little math ahead of you here just so I would, for time's sake, but basically if I take 5 and divide by 3 in my calculator or by hand, I'm going to get 1.6 repeating. If you take 13 1/3 and you divide by 8, you're going to get 1.6 repeating because they are equivalent. They should be equal. So when we simplify it down into a decimal version, it's really easy to double check that they are in fact equivalent in value. So that's what we're doing for these. Okay, make sure you're pausing and trying this on your own. Same thing, we're going to cross multiply this. 3 has an implied 1 underneath it because 3 divided by 1 is the same as 3. So we get 15, 3 times 5 equals 1x. Again, you don't need the x, just showing you so you know where it came from. So x equals 15. So the ratio on the left is 3 over 1, right? 3 divided by 1. And then the ratio on the right is 15 over 5. The ratio on the left and the ratio on the right are equal because both rates simplify to a decimal of, well, 3.0, right? They're both equivalent to 3. 3 divided by 1 is 3. 15 divided by 5 is 3. That's what we're looking for. All right, here we go again. So now we're going to cross multiply. We're going to get 5 times 7, 35, equals negative 2 times y, negative 2y. Again, cross multiplying. So now we divide by negative 2, divide by negative 2, and we get negative 17.5. Y equals negative 17.5. The ratio on the left is going to be 5 over negative 17.5. The ratio on the right is negative 2 over, oh, that's not a 2, there we go, negative 2 over 7. The ratio on the left and right are equal because both rates simplify, again, I did this math ahead of you, to negative 0.29 after I round. Okay, so again, you can double check these in your calculator. Divide 5 by negative 17.5, divide negative 2 by 7, and you will see that they are both equal to the same decimal. In other words, they are equal in value. All right, so here we're going to cross multiply. Key thing on this one, that negative in front of the 4/3 can apply to either the 4 or the 3, but not both, because remember, this represents a negative value of a number, right? And so a negative divided by negative is a positive, so make sure you do not apply the negative to both terms. But it doesn't matter if you apply it to the numerator or the denominator, because a negative divided by a positive is a negative, and a positive divided by a negative is a negative. All right, so I'm just going to keep it with the 4, and I'm going to do negative 4 times h equals 2 times 3, which is 6. And then I'm going to divide by negative 4, divide by negative 4, and I get that h is 1.5. So the ratio on the left is negative 4 over 3. The ratio on the right is 2 over negative 1.5. The ratio on the left and the ratio on the right are equal because both rates are going to simplify to a decimal of negative 1.3 repeating. Again, double check that. Divide negative 4 by 3, divide 2 by negative 1.5. Double check that those are in fact equal. All right, here we go again. 8 times x equals negative 2 times 9. 8x equals negative 18. X equals negative 18 divided by 8. All right. I'm going to let you finish that one up. I will put the answer in there for you in a moment. But this last one I do want to focus on and talk about. If you have 3 being divided by some value z equal to negative 1 being divided by that same value z, is that possible? Well, let's start by doing what we were doing. So we're going to cross multiply. 3z equals negative 1z. Okay, so is it possible to have 3 z's, 3 of some value, and have that be equal to negative 1 times that same value? That can't happen. So this is going to be a no solution situation. It is absolutely not possible to make 3 over z equivalent in value to negative 1 over z. So they cannot ever be equivalent. None of this applies because they are not equivalent. Yeah, so back to that last example because I hadn't done all the calculations yet. Let's do 18 divided by 8. Negative 18 divided by 8, which is negative 2.25. So on the left, our ratio is 8 over 9. On the right, our ratio is negative 2 over negative 2.25. The ratio on the left and right are equal because both rates are going to simplify. Let's find out what 2 divided by 2.25, negative, of course, is. It's negative 0.8. Repeating again, or positive, sorry, positive. A negative divided by a negative is a positive. Positive 0.8 repeating. Let's double check. 8 divided by 9 is also positive 0.8 repeating. It is. We are good to go. All right, don't forget to be working on your summaries if you are able. If you are not, at least read through it and bring us some questions. Hope you have a good day.